Hello. Short video on the solution to the pirate captain's wager brain teaser. Let's jump right to it. Okay. So let's recap what pirate's captain's wager was. So pirate captain captured you, and you're going to be killed. Except he gives you a chance to save your life. So what he does is he take two pieces of paper, write distinct real numbers. Let's say A is the smaller number, as B is the larger number, and he shuffles it. So you'll get 1/2 chance to get the smaller number and 1/2 chance to get the larger number. So he'll gives it to you, and you'll look at that number, and you're supposed to guess if the other number is bigger or smaller than the number you just see. If you kind of think about it, it kind of seems like it should be 1/2 because you're not really given any more information than the number that's given to you. But it turns out that there's actually a strategy you can take that gives you better than 50% chance of getting it correct, no matter which two real numbers that the pirate captain writes down. So let's talk about that strategy. So the way to do it is to generate a third number, random number, let's just say C. So what we're going to do is when we look at the number, let's say X, it could be the smaller one, but it could be the larger one. If the number we generated, C, is greater, we'll say the other number is also greater. If the number we generated is less than or equal to the number we just see, we guess that the other number is smaller. So there's three different things that could really happen. The number we generate could be smaller than the two numbers the pirate captain wrote down. In this case, you'll always be guessing the other number is smaller. And because the probability that the number you get is bigger with exactly 1/2 chance, the probability of being correct with this strategy in this case is exactly 1/2. Right? So if you see A, then you would have guessed smaller, which is wrong because the other number is bigger. But if you see the bigger number B, you would have guessed that the other number is smaller, which is correct in this case. The good case is when the number that we generate lands between the two numbers A and B. In this case, when you look at the smaller one, you'll guess the other one is larger. And when you look at the larger number, you'll guess the other number is smaller. So you're actually always going to be correct in this situation. So probability of being correct, if you're in case 2, is exactly 1. If the number we generate is larger than the two numbers, it's similar to case 1, except in the opposite end. We'll be correct if we were lucky enough to pick the lower number. And then the probability of being correct is 1/2. So I know this is not a probability class, so if you haven't seen this, you might look a little bit mysterious, but you can compute the probability of being correct and break it down into cases, right? So if you have a case 1 or 3, then you have 1/2 chance of being correct. So you multiply by that. If you're in case number 2, then the probability of being correct is 1. But the probability, so I mean, there's only 3 things that could happen, case 1, case 2, or case 3. The probability of case 1 or 3 is equivalent to 1 minus probability of case 2, because if it's not case 2, then it's either 1 or 3. So I'm going to replace that probability there. And then you could kind of distribute the 1/2 and combine like terms. So 1/2 times 1 is 1/2 here. I have 1 times probability of case 2 and negative 1/2 times case 2. If you combine that, you get positive 1/2 times probability of case 2. So, okay, we want the probability of being correct to be strictly larger than 1/2. So will be 1/2 plus something positive as long as you have some chance of getting into the case 2. So as long as this is positive, we'll have a strategy where the probability of being correct is strictly bigger than 1/2. Okay, so basically it means we want to have positive chance of landing in between any two positive real numbers. Okay, so there's actually many different ways to do this. If you've taken a probability class, maybe you say something like, oh, you could just use normal distribution or exponential distribution. And that does work, except it's a little bit less practical, I want to say, because if you're caught by a pirate captain, then it's unclear how you're going to generate this random normal distribution or exponential distribution right on the spot when you have to pick bigger or smaller. So here's a more practical solution, and it uses the rational density theorem that we just proved today. So what we do is we're going to create a rational number p divided by q. And how you're going to create it is this. You're going to start flipping your coins until you see 2 heads, right? And what you're going to do is the numerator is the number of coin tosses that it takes you to get your first head. So if it's tails, 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 heads, then it's 4 in the numerator. And then you start counting the number of additional coin tosses you have to do to get the next heads, the second heads. So maybe it's tails, 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 heads. That would be 6. So 2/3 is going to be your rational number that you're going to use. That's your C. And because the rational numbers are dense, and clearly this does give you any positive rational number, you have at least some chance of landing in between any 2 real numbers. So this will finish the job for the Pirates Captain's Wager problem. I hope you enjoyed it. I guess I'll end the video here. See you.